So in this question, we're told that a car starts from rest at point A and accelerates at a constant rate for 15 seconds, reaching a speed of v meters per second. The car maintains this speed for 60 seconds. The car then decelerates at a constant rate for 10 seconds, coming to rest at point B. Okay, we've been asked to produce two sketches. Firstly, a velocity time graph, and then an acceleration time graph. Okay, so let's put this together. So here we have our axes, and we'll start off with some acceleration, then constant velocity, and then deceleration. We know that the acceleration happened for 15 seconds, and then we maintained a steady velocity, a constant rate, for 60 seconds. So that will take us up to 75 seconds. And in the last 10 seconds, we were decelerating. So here's all the values I would want on my velocity time graph, including the unknown velocity that we maintained for the 60-second period. Okay, the acceleration time graph, I'm going to draw in line with this. I'm going to draw it exactly underneath. Let's just make sure that these points line up. And we have three different accelerations. We have positive acceleration, we have no acceleration or zero acceleration, and then we have negative acceleration or deceleration. So these are the three portions that I want to show. So the first 15 seconds we have positive, 60 seconds we have zero, 10 seconds we have negative. So I could leave this, but I'm also going to give an expression for the amount of velocity. We know that the velocity matches the gradient. So in the first 15 seconds we had an increase. The change in velocity went from 0 to v. So the change was v, and it took 15 seconds. So v over 15 is the acceleration that we had for those 15 seconds. Similarly, in the last 10 seconds, the velocity went from v to 0, so that's negative v, and it took 10 seconds. So negative v over 10. This is how I would label my acceleration time graph. Part B of the question gives us the distance that was traveled as 1,015 meters. We're asked to find the unknown value of v. So we're going to go back to the velocity time graph, and we're going to use the fact that the distance is going to equal the area under the velocity time graph. Okay, so that's 1,015, and here we have the formula for the trapezium. So half the parallel sides added together, the top being 60, the bottom being 85, multiplied by the distance between them, the perpendicular distance between them, which is v. Okay, rearrange, we get 2030 equals 145v, which means v equals 14. So that velocity that we didn't know was 14 meters per second.